Welcome everyone. Good morning, midday, good afternoon, wherever you may be attending this webinar. So we'll get some things started here with the Laser Tech and Seiler mapping best practices workflows. This is being recorded, so you will all receive a link after the webinar. We'll go through some introductions here and some housekeeping items before we do start the Laser Tech portion of this webinar. So again, welcome to Seiler and LTI webinar, Ask the Experts, Best Practices with Laser Workflows. So a little bit about Seiler Instrument. Seiler Geospatial is the division that our mapping division is within. This is our 75th anniversary. Headquarters is in St. Louis. Other locations that we have throughout the upper Midwest are Omaha, Nebraska, Kansas City, Missouri. We do have a satellite office in Iowa near Des Moines, Milwaukee, Wisconsin, another satellite office in the Chicago suburbs, Indianapolis, and also Wixom, Michigan. So with me from Laser Technology, LTI, we've got some guest speakers that are going to talk about LTI product line and applications that they have, and also that work with third-party software such as Trimble apps. So with us is Steve Colburn, applications training specialist with Laser Technology based out of Colorado. We also have Derek Resch, senior product manager of the professional measurement division of Laser Tech, also based out of Colorado. Brian Ferry, he's our Northeast sales manager down in Atlanta, and I will be doing the moderator portion of this. This is Jay Reister with Seiler Geospatial Senior Mapping Tech Support. Also with us, checking over on the questions in the chat session, are Joe Maddai from our St. Louis office, and also Dan Horn from our Wixom office in Michigan. So our agenda this morning, or midday, depending on where you're at, we'll be covering lasers 101, measurement routines, the TruPulse models, also GPS or GNSS laser offsets and what that consists of, apps and connectivity and integration, industries and applications. Then we'll go into a deep dive of Trimble hardware with LTI products, and of course stressing when and why to use laser offsets based off of safety, speed, efficiency, tough GNSS environment, and then we'll follow up at the end with a TerraFlex overview and the new offset routine within the application called Trimble TerraFlex. So with that, a couple housekeeping items. Please do ask questions during the webinar. We do have several people that will be monitoring the Q&A. We'll be bringing up some questions during the presentation too. There'll be 4 polls, so make sure that you have your cell phone camera, app, or QR reader available. And then towards the end, there will be a drawing for the Trimble DA1 Catalyst antenna with a 10-hour on-demand subscription of precision accuracy. So with that, I'm going to hand this off to the Laser Tech staff, LTI, to give us a presentation on the laser technology and the LTI TruPulse product line. Brian?
Thank you, Jay. Thank you very much. Everyone, this is Brian Ferry, the Northeast Sales Manager for Laser Technology. Before we get into the presentation, we wanted to tell you a little bit about Laser Tech, in case you haven't heard of us, or maybe you do have our products. You always wondered about who the corporation was behind the products. We've been in business for over 3 decades, over 30 years, actually 35 years to be exact. We are proudly here in the United States of America, just outside of Denver, Colorado. We do pride ourselves on superior service and support, and we put our money where our mouth is there. When you call our headquarters, you get a human being answer the phone. You don't get voicemail or someone pressing 1 or 2 or 5 or 7. You get a human being who will put you to the right person and where you need to be. We do have a rich patent portfolio. We hold over 65 worldwide patents. And we do our professional measurement business, we do that through an extensive dealer network. We are proud to partner with dealers such as Seiler. Seiler has been a partner of ours, a very valuable partner of ours for several decades. And we're very proud to be partners with Seiler. We are ISO certified, ISO 9001, and our motto is we have quality through innovation and dedication. We've made one recent change here at Laser Technology. We've had our logo that has been with us for quite some time, and as times change, so does the need for a new logo. So we've rolled out a brand new logo. In fact, you're the first public audience to see our brand new logo here at Laser Technology. People call us Laser Tech, so we thought we'd embrace it. So this is our new logo here. We hope that you enjoy it. You will start to see this logo on all of our lasers and all of our presentations. So with that, I'm going to introduce you to Derek. Derek Reich is our Senior Product Manager. Derek has been with us for several decades, and I'll let Derek take it away.
Hey, thanks a lot, Brian, and thanks, Jay, and everybody at Seiler. And so just talk about our laser rangefinders. We do manufacture, design, and distribute these laser rangefinders just outside of Denver, Colorado, what Brian said. We do pride ourselves of manufacturing them here in the States. And so with these professional laser rangefinders, we specialize in pulse laser technology. What that kind of means is reflectorless technology, where I can get a measurement, a range to almost any type of object in a line of sight. I can't go around corners or anything. So if you can see the object and it's got some reflectivity to it, we can get a measurement to it. We get over some distances over 3,000 feet, but I'll talk about specifications here shortly about the different models. Also built in our lasers, we have a tilt sensor. So you can see here with that tilt sensor, we can measure inclination values or vertical angles, plus or minus 90 degrees. And so we've got those two sensors built in on all our lasers. In different models, we have a compass sensor. That compass sensor measures magnetic north. And so with that, we were able to get our azimuth measurements basically off of magnetic north. You're able to also put a setting in there for true north if that's needed. You can just apply a declination or an offset in the unit itself, and you can get true north. So we've got all these different sensors built into the lasers, but also that we have different routines. Let me show you how that works. Sorry, we've got different ways that it works. Different diagrams here. On the left is our 2D lasers. What it is a slope distance, is a kind of line of sight, and the inclination or tilt is a degree of inclination. You press the fire button and those two sensors measure, and then with those values, we're able to calculate that VD or vertical distance and that horizontal distance also. When we incorporate a compass sensor in, the diagram on the right, that AZ value or azimuth. Again, with the press of the fire button, all three sensors measure, get a result. And then we calculate on board that vertical distance and horizontal distance. And now moving on to different routines we have built inside. So we have a height routine, a 3-point height routine is what we do call it. We need to get a measurement to the object, just a distance to it. And then we get a base inclination and then a top inclination value. And with those three values, the instrument automatically calculates that height value. You don't have to go from base to top. You can also get a distance, and then go to top angle and then base. And so that also calculates a height value. One good thing we like about this routine is, say if I needed to measure quite a few attachment points on a utility pole, I need to do the heights on several attachment points. Instead of doing this routine over and over for each one of those attachment points, what we do is you can do this multi-height routine. What I mean by that is we can establish a distance to the object, then establish that base angle, and then what we'll do is take a top angle to the first attachment point, and it calculates, we get the height value, and we also output that through Bluetooth or serial port to an app that we'll be talking about. You get that height value, From there, if I just press the back arrow button on the unit itself, I can reshoot that top angle again. So I can move up to the next attachment point, press the fire button, get that top inclination value, calculates a height, outputs, and repeat. So I can do multiple measurements on a utility pole. Instead of redoing the height, the 3-point over and over, I can set that distance and set that base angle and do multiple top angles to get height values. Not only that, we have what we call a 2D missing line routine. What I mean by that, we can measure the distance between shot 1 and shot 2. This is a kind of the 2D value. So I take a shot to the top of a slope and then the base of the slope, and then I get all these different values calculated in the unit. You can see everything in the dotted line is all the calculations. I can also, if I wanted to put in a different units of measurement, I can get the slope percent of that hill. Or if I wanted to get the measurement of a leaning tree, the length of the leaning tree, I can do that with this 2D missing line routine. And again, you don't have to go from top to bottom. You can go from bottom to top, however you'd like to do that, and the calculations come out correct. So if you were doing a top to bottom, you would get that VD value would be negative. But if you go bottom to top, that VD value would be positive. So that's our 2D missing line. When we incorporate the compass into the laser rangefinders, now what I can do is a 3D missing line, or like I can get measurements like a span or a width. I take, I stand in a safe location off the side of the road. I can take a measurement to the pole to the right, then a pole to the left. And with that horizontal angle with the compass, the instrument automatically calculates the distance and values from shot 1 to shot 2. It even calculates the azimuth value. So it kind of acts like I walked over that pole to the right and shot to the pole to the left there, just a straight measurement. But I'm standing away from it in a safe location and just taking 2 measurements right to left or left to right, however you'd like to do it. And so again, all that calculates out to the all those calculations right on board. So the models that do all these measurement routines, we've got their TruPulse 200 series, which is a 2D, what we call it. So it's got that slope distance and inclination capabilities. We've got a TruPulse 200L. You can see the accuracies here is about 1.5 feet on the range accuracy, and you can see our price points down below. The TruPulse 200 has been our flagship product, and it's been one that just has been around for many years. One thing I want to note on that is just recently we've increased the range accuracy on this unit. Now you can see it's down to 8 inches. So that's been a huge improvement on this unit. And then on the 200X is our most accurate pulse laser that we've developed. It's got a range accuracy of 1.5 inches, and you can see that inclination accuracy is 1/10 of a degree. So it kind of moves up in the TruPulse 200 models. You can see the different ways the accuracy moves or increases as you move different models. When the compass sensor is built, or the compass sensor is built in, we call that the TruPulse 360 model. With the 360 model, you can see here we've got two different models. The TruPulse 360R is our ruggedized waterproof unit, and it's kind of more like a horizontal housing or like a binocular style housing. That's only the difference between the two units. The specifications are the same. Again, the range accuracy we have increased, but also on this unit with the compass, we were able to increase the accuracy on this also. It was a plus or minus a degree. Now we're down to 0.5 degree. Not only that, what we've done with these lasers of an increase in range accuracy and azimuth accuracy is we increased our target acquisition. And what I mean by that is I can hit smaller targets at longer distances now, and actually much faster. And we're able to do that about 35%. So like if you were hitting a conductor at 100 feet, now you can hit it at 135 feet, which that's quite a bit of increase there. So we've increased that target acquisition to smaller targets and also to pick up targets quicker. So we got a poll that Jay talked about. We just want to be using your phone, everything like that, or be able to type in that link. We just want to see if you do use lasers and which ones you do use. So if you can take a moment here to do those polls, that'd be great. and I'll turn it back over to Jay.
Thanks, Derek. So we'll give you a few moments here to get that QR code up and running, or if you do need to manually type in the link, share the results here. Okay, just checking. Can I get a confirmation from those on the panel? Can you see the survey 1, 2, 3 results coming up?
Yeah, Jay, I can see it.
Yeah, we
Yes.
can. Jay.
Perfect, perfect. Okay, so far, we're getting some results popping in here. Don't have a timer set, so we'll just stop it here in a few moments after looking at this. So, TruPulse looks like we've got TruPulse 200 user, TruPulse 360 at least 4, 200X. We got a few. None on that, and other, we don't have anything going on for other uses or other lasers. Okay, sounds good. So here's the percentages here. So it looks like a majority are using the 360 TruPulse. Steve, would you like to give us an overview of GIS field data collection workflows with laser technology products?
I would, Jay. Thank you, and thanks to you and Seiler for helping us put this on. Actually, if it's okay with you, I would like to address one question that did pop through.
Sure.
Someone was asking about the 300 model, and I believe they were referring to our TruPoint 300 product that we sell. So Derek didn't mention that in his section there because it's typically not used for GIS data collection, which we're kind of focusing on here, integrating with Trimble GPS and that kind of thing. So that's why that product was left out. We can certainly get you more information on it. The difference with that product is it's very, it uses a phase laser, so it's very accurate distance, and it does have horizontal and vertical angle sensors on it. So it's a little mini total station, really meant for shorter range, higher accuracy type applications, even indoor mapping, BIM and that kind of thing. So great product for that. I'm not going to focus on it here for this webinar today though. So to carry on and talk a little bit about the workflows now. What we have listed here is like a typical GPS, GNSS alone type workflow. And right there, number one, walk up to the features. You have to occupy the features with that GPS antenna to get a coordinate for it, right? So there's your first challenge right there. If your target's behind a fence, you know, on private property, something like that. So then we still, even with more constellations coming on, we don't have to worry about it quite as much, but just positioning, you know, the antenna, making sure you have a clear view to the part of the sky that you need. That can be a challenge sometimes. So you, if you can occupy that point, you collect your point, you wait for your accuracy, you go through your metadata and typing in your notes and everything, and then you accept the point and you carry on to the next one. So that's just a typical GPS alone workflow. You can see it's got some challenges to it. Okay. Next slide, Jay. So we talked about a little bit about them, limited access, and Jay will go over some of these later too when he talks about TerraFlex. But there's some of them on here that you just can't get around. You know, some of them are tough for GPS, some of them are tough for laser. The visual obstructions, as Derek mentioned earlier, it's a line of sight technology. So if the foliage is too dense, you know, if your target's around the corner, you're not going to be able to get a distance to it. And it may be snowing so hard that you just can't get the shot. So there's some challenges out there for field data collection. I'm sure you all know. Okay. So let's introduce this concept of laser offset then. What do we mean by that? The laser product can bridge these troubled waters you see here. You need to position that tree on the other side there. You can't get to it where you are. So you can take your shot with the laser And if you've got distance and azimuth, boom, one shot and it's on your map. You know where you are, you apply that azimuth and distance, you can calculate that remote coordinate. So that's the basic concept. And we'll go over different methodologies too, but this is it. So some of you will introduce this concept also of LaserGIS. Some of you may recognize the name as an extension to Esri's ArcPad product that we developed years ago. Some of you may have used it before. It enhanced the whole ArcPad laser experience. But we've expanded the concept to really include this integration of GPS, laser, some kind of mobile device, and then an app. You know, you've heard of BYOD, and you can say the same thing for apps too. And all these combinations with, as technology advances, we're able to drive the accuracy down. The laser can contribute some, the GPS contributes some, but we're able to do a lot better job than we used to with precision. So I'll now go over a little bit, speaking of apps, a few that we have written, and then some other third-party ones that are out there that make a good integration between GNSS and laser. So let's start off with our Measure app. It is written for Android and iOS, and it'll essentially just capture the laser data, your distances, inclinations, azimuths if they're there. It'll capture that laser data. It'll allow you to take a photo, some basic, you know, note taking from pick lists and categories and things. It'll also accept height values and missing line type measurements that Derek talked about earlier too. So you can add those into your records. It also will georeference that photo, so you can get a rough location of where you are. And it doesn't do the GPS offset function, but can go a long way to collecting data in a real simple mobile format. And then we have our MapSmart app, which is written for Android now, currently working on an iOS version. But this, we've given full capability now. You can connect up to any GNSS receiver, output that data, maybe through location services through the device. MapSmart will consume that data, give you a nice tight origin point to take off from with laser shots, laser offsets, or you can traverse off into the woods or the canyon or something like that. So a real flexible app with all different types of methodologies to collect data, even a volume routine on there where you can get cubic yardage of stockpiles or even excavations. So another one that we've been interfaced to, a local developer here in the Denver area, Geospatial Experts. They've written the latest incarnation is called GeoJot Plus, and it's got a great field app. Again, we'll go on all the mobile platforms, photo-based type workflow where you take the picture. It does have the laser offset capability where you can position that pole you see in the screen there as well, and then go ahead and record attributes for it, as well as bringing in height values. So you could even turn this into a pole inventory type thing where you could position the pole and then record all the different height values, as Derek mentioned earlier, right down the pole. So a great app, and has direct shape file output right into Esri's product for your GIS.
Maybe Joe wants to chime in on this. He's worked with some customers doing some next gen cell tower and integration for 5G. Okay, we'll move on if Joe comes on later.
Yeah, no problem. So another exciting thing that happened just within the last year is that Trimble has integrated the lasers into their TerraFlex product. It's always been there in TerraSync, but as we migrate away from the Windows mobile platform, they've now integrated into TerraFlex. And if you haven't seen it before, wait until you see Jay's presentation here on it. It's just a great laser interface, and integrates seamlessly with all the Trimble hardware, of course. So We'd like to do another poll question now. And let us know what apps you're currently using, maybe with the laser or without the laser. And there's actually 2 questions on this form when you go to it here. There's one about the apps above, and if you can scroll down and answer the one about the OS, whether you're using Android, iOS, or Windows. Thank you.
Thank you, Steve. So we'll give a moment or two here for people to use their camera app or QR code reader and bring that survey up.
So while we're waiting, Jay, there's another chat question that came through about working within a trench. And this can be another great application for the laser. Trenches are often, dangerous to get into and things like that. So you can stand on the rim of the trench in a safe location, grab your GPS coordinate, and then measure down into the trench and get that critical, scene location or something like that.
Yeah, that's great idea, great example, especially if you're putting in buried pipe or you found a leak and you need to document that location without getting in harm's way. Especially if a backhoe is moving in that area, stay out of harm's way for sure. Safety's key.
You bet.
Bring up the poll here. See what we got for results. All right, again, give me a yes or no if you can see some results here, panelists.
Yeah, they're up.
Okay. Looks like we've got someone said yes to measure, 1 person, 2 on MapSmart,
Nice.
ArcPad a couple, LaserGIS, TerraSync, TerraFlex, and none. So that means that some users are using their lasers or TruPulses just as is. If you do want to maybe volunteer that information in the chat window as far as what your application or use case is, we'd be interested in learning more about just using the laser standalone. All right, and then here is what OS are you using? And not surprising, iOS kind of leads the way here, followed up by Android, and then Windows Mobile and Windows. Okay, and that could be a variety there. It could be anything from 7, 8, 10, but most likely it's 10. All right. Good results there.
Yeah, great.
And Joe, are you on?
Like if you're in the pole audit industry and doing utility audits, these laser rangefinders really make you be safe, because there was times where I would come up and there would be a dog in the backyard, and I don't want to go in there, get attacked, get hurt, get injured. And really just drives home the point of laser tech being these devices that can keep you safe and out of harm's way, and making sure you can get those accurate measurements within a certain degree of what you or your customer is expecting.
We'll move along here. And Brian, I believe you're going to be discussing some applications in certain industries.
All right, thank you, everybody. Now that you've seen a little bit what the lasers do and what some of the solutions that pair with these lasers can offer you, what kind of industries or what kind of applications do these lasers have a real nice fit into? In public works, we have a big following on laser offsets and heights. You can stand someplace safe and get the measurements you need without putting yourself in jeopardy. A lot of the public works folks have to map out every fire hydrant, every gas meter, every opening in the road, and that this allows that mapping to happen safely off the roadway without having to stand in the middle of a road with a GPS receiver. You can do positioning and slope as well as area with all our lasers as well. They have all that technology built in, especially when you partner them with an app. And that takes us over to electric utilities. Electric utilities is a big user of our solutions because they need to measure span and sag and tension. And when you partner our lasers with some of the software solutions that you saw earlier in Steve's presentation, they give you the measurements you need and do the calculations for you. They help with vegetation management. We call that danger tree. If that tree is to fall, is it going to fall into power lines and cause outages for thousands, if not millions of people? and cause a whole lot of headaches. It helps the electric utility people manage those danger trees. They do pole audits that we just spoke about. I heard Joe had done that for a number of years, and the pole audit industry is huge. One thing I've learned in this business is that everybody owns a pole out there. Those poles just aren't put there for free. And because those poles are in place and somebody wants to attach a line to that pole, they have to follow the rules of the person who owns the pole, and they have to pay them rent. So people have to come by and inventory those poles and make sure that the poles are in good condition. So that's where the pole inventory folks come in. The GIS mapping for electric utilities is a very large user of ours, where they need to map out their assets. Clearance, you have these utility lines are in construction areas, and the last thing you want to do is have a backhoe or something take down a line and put themselves or the public in danger and put more people out of power because they didn't know the clearance that they had with that line. The height routine built into our lasers help the operator know the height so that they know not to go over it. And that is a great use example for our solutions in the forestry applications as well. That's coming up next. You want to switch the slide there for the electric utilities? Oh, I'm sorry, we're in forestry. My bad. I'm sorry. I'm ahead of myself here. So in our forestry, we do have some other solutions that can get the diameter of trees. We call that the basal area factor. You can map out the area of forestry assets. You can do stem mapping. It helps with survey. Again, using that height routine that's built into the laser. I can't say enough about that. Our lasers have built-in height routines that let foresters measure their height of trees and make sure that they can be harvested safely. And then we do have a volume solution as well that can get log deck volume coming in there. Next. All right, general construction. So you have a lot of construction companies out there that need to take some measurements to work safely in their construction sites. You can get the heights underneath of overpasses or bridges. When you're going to position a crane, how are you going to make sure that crane is positioned in such a way that it is a safe distance away from other things around it that may cause damage? You can do site inspections, map out your facilities. Again, we talk about that clearance in the construction industry. You're putting these backhoes in places underneath of wires. You need to make sure that you know the height of the wires so that the operator can do that safely. Our solutions also have a volume calculation where we have some aggregates on construction sites and you know how much is there. See, they need to order more. They need to do some inventory. Our volume calculations are very well received in the industry. We have a lot of applications that work with not only our lasers as standalones, but also when you partner them with either our software solutions or someone who has integrated our laser measurements into their software solutions. And then when you attach a GPS receiver to that, now you have a complete solution. You can safely map out those GPS locations from a safe distance. You don't have to stand next to it with the receiver. That GPS offset that Steve talked about earlier is huge. It keeps the crew safe, it makes them more productive, and you can get your measurements that are needed for that particular survey in an efficient manner. So that takes us to the next poll. And what we'd like to know is what industries you work in. So again, using either the camera on your cell phone, or if you can want to type in that manual address there, go ahead and take that survey and tell us what your purpose is so we can gather some information.
Thank you, Brian. Yes, I'll give a few seconds here to get some results generated, and I'll switch screens.
Just wanted to bring up another chat question that came through earlier in case everybody didn't see it, Jay.
Sure, go ahead.
Someone asked about remote control on the laser. When you're trying to target some of these very small objects like electrical wires and things like that, sometimes having that extra stability of leaving the laser alone and remotely firing it instead of pressing the button on the unit can be an advantage. So the app typically can control that. The Measure app, the Map Smart app that I mentioned, and others will allow you that remote control button on the device. It's a good question.
Yeah, that's a nice feature.
Yeah.
Thanks for answering that.
Yeah.
All right, we're looking at the results here. Give me a yes or no if you guys can see these.
Yep.
Okay, so it looks like we've got 2 answers for construction and gas. GIS seems to be the main industry at the moment. Telecom coming up next with water, wastewater, and there's some in the other category. Be curious if someone wanted maybe put a dialogue in the chat about what specifically in other, because there's at least 6 there. It's a good chunk, 42%. Good range of industries. Again, thanks, Brian. Here are some LTI resources, some very good ones out on the YouTube channel, specifically with the 360 series and calibration, magnetic interference, why and when to calibrate a 360. We also have some out on our support blog too. So please do check those out. These links will be live when you do get a copy of the video. If not, please do email us at mapsupport@SeilerGeo and I can get these to you. Also too, there's quick reference manuals for the 200, the 360 series, and then also to other specifications down at the bottom. And the main link down at the bottom is all 3 major TruPulse lines in the 200 and the 360 series listed on that front website, the TruPulse Laser Rangefinder.aspx. So we're going to switch gears here and get into the specific TerraFlex app with LTI TruPulse configurations and workflow. So with me here is Joe Maddai and Dan Horn, again, giving them second introductions here. So if you guys want to say hi, you're more than welcome to. Otherwise, please do give your input throughout the PowerPoint if there's something I'm missing.
Hi again, everybody.
Hello.
Thanks, Joe and Dan. All right, so as we talked about earlier, Derek went over quite a bit as far as the differences between the 200X on the left there and the 360 on the right. We will talk about them here in certain workflows when it comes to the TerraFlex adaptive offset workflow. So some specifics real quick, they would be on the data sheet of TerraFlex. What is the minimum Android operating system, 4.4, and also for iOS, it's iOS 8, and for Windows 10, TerraFlex also works on Windows 10 tablets, whether they're Trimble based and or your standard Windows 10 tablets. But do contact us with any questions as far as specs and integrating them with TerraFlex. And of course, also external GNSS receivers. So speaking of that, here's a screenshot of product line that currently does work with TerraFlex, the latest version, especially for the adaptive laser offset workflow. So down the bottom left, you got the TDC 150, then the Nomad 5, the TDC 600. Bottom right, there's 2 different Windows 10 tablets, the T7 and the T10. And then up top, you've got your R1, your sub-meter receiver. In the middle are Catalyst DA1 antenna that can be paired up with different subscriptions of accuracy of the Catalyst subscription. And on the right is the R2. The R1, R2 are Bluetooth, so they could connect to any one of the data collectors down below. The one in the middle, Catalyst DA1 antenna, currently is Android only compatible because it does use a USB cable. It does standard have a micro, but you can put on an adapter for the C adapter that would be for your more modern Android devices. Kind of a recap, going back through a little bit of history, TruPulses have been around and with Trimble products for quite a while, longer than I've even been here with Seiler. When I first started, I started pairing up TruPulses with the 2003, 2005 Geos and later after that, and Recons and a few other things and Nomads. So they are compatible with Windows Mobile, but again, it would be dependent upon the application. So those older applications would be ArcPad or TerraSync. For going for the newer Android products, that's where we are now into the TerraFlex line, the next gen, let's call it, app, Android and or iOS. And as you can see there, I've listed out the Android devices. that are compatible with TerraFlex and what lasers, the TruPulse 360 and the 200X. As far as Windows 10 tablets, as you saw earlier in Derek's presentation, 360 and 200 are compatible. And so also then with TerraFlex. You could always then pair up any of your Trimble Android devices, that whether you own an Android phone and or tablet, or you have one of the Trimble ones, if you're trying to get higher accuracy than what is embedded inside, say like the TDC 100 or the TDC 600 or the Nomad 5, you can then pair it up with an R1, R2, and or Catalyst, depending on compatibility for that. Then also too, iOS devices can be Bluetooth paired up with the R1, R2 for higher accuracy. So say you have an iPad or an iPhone, and you want to use the TerraFlex app with a 200X. So that's kind of the breakdown as far as Trimble hardware devices with TerraFlex and the TruPulse 360 and 200X. A lot to digest, but it's kind of spelled out there. If you got any questions, please let us know. So offsets, Brian, Derek, and Steve have talked about this several times, key points within the presentation so far. So how does it work? So basis is we have a GPS location where we're standing, and then we're going to measure out to something, how far away something is from us relative to our GPS reference. And then the calculation can be computed by the app to give us that distance measurement. And of course, even too, with the 360, if you got a compass, that is taking into account the compass bearing. So what's the problem with this? The problem is you may not always be able to get good GPS or GNSS within the areas that you're at. And then also too, for safety of workers, you do not want to send your crews out into the middle of the street to try and GPS a manhole lid or a water valve or other assets that may be in the median that it just may be too unsafe to get involved in a downtown setting or a busy highway. So enclosing the road can be quite expensive and time consuming, and or has to be done at night, and nighttime construction is not necessarily the safest either as far as trying to block off a road and do mapping or surveying. So then the other issue that we could have too with GNSS, and if you've taken classes from us, you've heard us talk about or been to some of our workshops, you've heard us talk about urban jungle or urban canyon. When you get into a downtown type setting, you kind of are losing some of your sky of the satellites, you know, on the angles to the south, to the west, to the east. Same concept would be too if you're in a forest, in a park type setting, and or maybe in a canyon or river valley, you lose line of sight. So you're going to have to get yourself in most optimum area to get good GNSS. And then from there, you could pair up with a laser to then get you that offset to get within certain specifications, accuracy of say a tree or a pole, or even like what Derek and Joe were talking about, safety. I'm not going to go inside someone's fence and put my life or myself in harm's way. So standing outside of that area and getting the offset is definitely a good solution. So also too, efficiency. If I've got multiple features, say in a park or in a forest to try and collect, I'm not going to want to go up to each individual one and try and GPS them. That's going to take time. Also, I'm going to lose probably some GNSS accuracy and satellite constellation while doing that process. So if you can speed up and make your job workflow a little bit more efficient, then by all means do that with a GPS laser offset. So offsets in TerraFlex, how does it work? We're going to talk about that here in the next couple sets of slides. And if there are any questions coming in, Joe or Dan, please let me know. So kind of the old method, whether you were doing this with TerraSync or ArcPad, this is a screenshot from a TerraSync workflow when you would go into options offset and you would either log your GPS position first or do it second. And then you would do a distance bearing with the 360, or you do distance with the 200X series. So it depends on what you are selecting within the actual application and also what device, what LTI product are you actually using, then defines what your workflow is for doing GNSS offsets. The newer way within TerraFlex, and it will be kind of like a heads-up display on screen, follow the prompts. This is called the adaptive offset method. So within TerraFlex, this is new as of December last fall. You can do offset workflows within TerraFlex. Again, Android, iOS, Windows 10, depending on, again, what platform you're using and what laser you're using, which we'll get into. The air combines both GNSS and the laser measurement. So what you're going to get up at the top, or actually down at the bottom in this case, is that it's telling you you're at 23 centimeters of accuracy, and that's combined GPS and also the air within the laser. And again, Derek brought up a good slide showing you the differences between the 360 and the 200X. The 200X being more accurate, but the 200X does require you to do the two-step distance routine. And again, here's an overview again of the 200X and the 360. Derek, if you want to give any input on this, on how this is crucial when deciding what apps you're going with and or what workflows.
Yeah, sure, Jay. Yeah, so we worked pretty close with the TerraFlex development team, and they concentrated on these models here, the 200X and our TruPulse 360 and TruPulse 200, to integrate into the workflow. And like Jay was talking about, this adaptive workflow is one when we talk about connectivity. Jay will talk about it here in a second. Is one when we do connect to the laser, the app actually knows the accuracy of each one of these models. So Jay showed the accuracy of that offset. So it takes that into calculation right off the bat. So, which is really nice about knowing which laser you're connected to. So, and then also Jay's going to talk about different workflows with the lasers. Our lasers do interface differently on different operating systems. And so on the next slide, kind of break that down, is like the 200X is the only one that works with the iOS interface. We do have the Bluetooth module in there, is Apple approved, but the other models we have, the TruPulse 360 models and the TruPulse 200, works with Windows and Android TerraFlex. So there are different operating systems out there, so it all depends on which operating system you have. Kind of depends on which laser you want to put in to use too. So this is the breakdown of the operating systems.
Yes, thank you, Derek. I'll show some examples here of how the setup goes. So real quick, here's a screenshot just to give you a visual. So of course this is overdone, but in order for me to take a picture, I had to put the bipods up. So this is a setup with an R2 subfoot. Could also be centimeter also. It's hard to see. That's why I kind of put the two screenshots up there of the 200X on the left and the 360 on the right. It's just the magic of Snagit editor. But you can see connected to the pole, I do have my 360 on that pole. Just doesn't show up very well. But this was a test I did in my backyard, which you'll see at the end. I've got a video on that. That ginkgo tree has got a very wide span on it, so it's hard to get under there with the GPS unit. Within the application, like Derek was mentioning, depending on Android or iOS, and of course depending on what version of the TruPulses you're using, it recognizes within the TerraFlex app after you Bluetooth up to your device, whether it's Android or iOS. And again, there's different things that go on between Android and iOS on how to make sure that you are staying connected to a Bluetooth device. In the iOS version, you do have to force that connection. Android, it remembers it. But within the settings of TerraFlex, as you see down towards the bottom, I've got highlighted in red, it recognizes the actual name and also the serial number, part number of the Laser Rangefinder 360 on the left for Android. And then on the right, same concept, the 200X iOS, it knows that it's connected. And that is crucial coming up here in a few seconds when I show you another slide. Also, something is brand new that came out this spring. You can actually now put in, where is that laser mounted on that rod? So I've got a 2-meter pole here, and my R2 is on that. That's what its height measurement is. But you can then also put in, where is that, that laser height actual mount point? And Derek or Steve, if you want to explain why that is important, feel free.
Sure, Jay, I can. You know, historically, we really only needed a lat long position for GIS, right? Elevation wasn't all that critical in a lot of cases. Well, as not only the position accuracy increases, our desire for good elevation data is increasing. So the GNSS can give you better elevation, and now the laser can carry that good elevation with you. You're not going to lose anything. If you need accurate elevations for your laser offset shots, you can get it now with this laser height value in there. So it's a great advantage.
Yep, and that's recent. That just came out a couple months ago. So that was a new enhancement in the latest version of TerraFlex. All right, so the adaptive workflow that we were discussing. So this is what it looks like within TerraFlex, and this is kind of key. So back on that other slide, within the settings, it knew what laser it was connected to. And so if and only if you have a laser connected and on, you will only see this particular X with the location marker at the bottom of your settings screen. If you just pulled up your phone or iOS device and just paired up to TerraFlex with just an R2 and R1, but no laser, you will not see this icon. So it's kind of intuitive. It knows to turn on that functionality once a TruPulse has been connected to it. So that's kind of handy. Also too, you won't see it right now, but back in the video at the end here, if you do click on the dot, dot, dot in the lower right, it actually does bring up and explains what all three of these icons do within the app. And as always, you're always going to see your GNSS accuracy up in the upper left-hand corner. And so here's the workflow basically. After you've clicked on that little X with the marker, it's going to prompt you. I like to call it the old, next, next, next when installing something, or follow the bouncing ball. This basically what we're going to do is a workflow that is going to step you through. So you'll log your GNSS reference position first. And this doesn't matter if you're using the 360 and or the 200X. You have to start somewhere, so we have to get that origin. Next step, it's going to prompt you, please fire the laser. It's waiting. Once you fire the laser, you will then get a calculated estimated accuracy down here in the midsection, lower midsection. Offset has been captured, and it is at 23 centimeters. So this was done with a 360, and it gives you your combined information that is both GNSS and also the specs that the accuracy of the TruPulse can actually provide to you. And so that's step 2, of course, after shooting the GPS. If you like that shot, by all means, you can click accept and move on, especially with the 360, because remember the 360 can just do the distance bearing one-shot routine. If you do not like that shot and you wish to try to refine or improve it, that's where you can get into this 2-step adaptive workflow, and that is what is required with the 200X. You would click refine, and then you're going to be prompted. It's a little bit different. This is going to be Android. Android's going to prompt you with these windows, these triangular windows, to tell you, hey, go left or right 90 degrees. You do need to position your GNSS at another location, and so that we can try and do a distance routine, and where those intersect, that's where your location of your features should be. You would hit log, and then from there you would get a combined resolution from both GPS shots and both laser shots. And this is where you can either accept, or you have the option to go back and start over. So it is kind of a heads-up display, user-friendly, and then gives you your prompts right then and there as far as what your accuracy is. And again, you can either accept, or you can go backwards and start the process over again. In review, depends on, again, which laser are you currently using. You kind of have 2 options with the 360. You can run it out as what it normally is intended for, the single offset with the bearing. Again, make sure that that compass is calibrated and that you're not standing near any metal objects, which is discussed within the YouTube videos on calibration and magnetic hygiene. If, again, that shot is not what you intended it to be, or you think there might be, something wrong with maybe your GNSS signal, or maybe your VRS real-time correction, or you did forget to calibrate the laser, then you could start over. or move on to the refined technique and then move 90 degrees and get yourself your second shot. Depending which tool you're using, you remember the right tool for the right job. If you're going with the 360, it does have the internal compass. Does not necessarily require the second shot, but you can if you are inclined to see if it can get better. Also then too, keep in mind of magnetic hygiene on a spec sheet that I can always send out if you do need it. That does spell out how far away from certain metal objects you need to be distance yourself that 360 from. With the 200X, you don't have to worry about magnetic hygiene. It doesn't have an internal compass. You are automatically put into the 2-shot routine workflow. Basically, your shots can be refined also too. If you don't like them, you can start over. There are some TerraFlex resources that you have available. There was a social media post last fall from Trimble, Capture Features Remotely. This was a publication that they put out there in conjunction with Laser Tech on using the Trimble TerraFlex and TruPulse series laser rangefinders. There's also information on the Trimble TerraFlex website, the basics of what it is and the data sheets, and then also Trimble TerraFlex Getting Started guides too. So how are we doing on chats and panels? Do we have some other questions coming up before I move on to this poll?
We have a couple questions coming. The question that's asked is, when will LTI be working with Trimble and an Esri collector? The answer is we don't know. Trimble's a publicly traded company. Just stay tuned to blog posts, and I'm sure there'll be a big blog post from Trimble when this functionality does actually come to fruition to work with Survey 123 or Esri collector. Another question that I have here is somebody asked if they can you post-process the data with a GNSS shot and use laser rangefinder if RTK is not available? Yes, you can do this in both TerraFlex and TerraSync. TerraFlex you can post-process, but you have to use the Trimble Positions application with it to do your post-processing.
Good question.
Okay, so there's a question that's out here, and it's depending upon, it says, how would you account for laser height in TerraSync to obtain accurate elevations for features? Depends on what type of laser rangefinder and what kind of device you're using. If you are using a Geo7X and have a built-in laser rangefinder, you would go into the rangefinder app and set your elevation in there, also needing to run a monopole. So there's a bunch of other questions that need to be asked before we can determine if you can accurately take elevations inside of TerraSync.
Well, let's go on to our last poll then. We're curious as to what future webinars you'd like to see from Seiler Mapping. Have one planned in the future here, late July. We are going to be working with the Trimble Positioning Solutions team, aka the Trimble VRS and RTX team. So they are going to be talking about real-time corrections and your options when using Trimble apps and other third-party apps. So stay tuned for our blog posts coming up here in a couple of weeks. End of July, 3rd or 4th week, we will have a Seiler and Trimble Positioning Services webinar. Okay, so hopefully most of you have gotten the chance to click on this QR code here. Suggestions for future webinars. Okay, let me know that you guys can see this.
We can see it.
Okay. Of course, because I didn't do a GPS location, you guys are all off the coast of Africa. Available GNSS devices and usage, Catalyst and various survey apps, setup for utility pole, audit best practices, that's a good one. Webinar specific to pole audit, all right. Brian, Derek, Steve, we might be having you guys come back for maybe one in the fall here.
We can do it.
Right. Well, we do thank everyone for attending. And if you do have any follow-up questions, please feel free to email us, support@seilergeo.com. Otherwise, feel free to give us a call if you've got a support question. You can also visit Twitter at SIMapSupport and see any recent posts, or tag us in there if you're out and about using GPS and laser offset routines. With that, that's our webinar for today, and I do appreciate and thank Brian, Derek, and Steve from LTI for joining us, and also Joe and Dan.
You bet. Thank you, Jay.
You're welcome. So with that, I'm going to stop the recording and sign off here, and everyone have a good afternoon and a good weekend.
Thanks, Jay.
You're welcome.